Hey, we're over here at the Builders Fair. We have the smart foosball table set up. Yeah, you guys see what's going on? Currently have a match going on. We got our builder here. If you could go ahead and introduce yourself, let us know what we're looking at.
I'm a solutions architect supporting the city central. Glad to be here. We are here this year with the Smart Foosball, and we had actually built this last year. What we have here is several serverless services being used in a very creative way. We essentially wanted to take foosball into the new era. We made it smart by adding sensors to the goals. So now we have IoT sensors detecting the goal, sending via Raspberry Pi. The event gets transmitted and invokes a Lambda function. That Lambda does multiple things. First, it generates a commentary by using Bedrock, which is a serverless way of invoking large language models. It stores the metadata in a DynamoDB table. It also triggers a goal clip process because we have Kinesis video streams capturing the live video stream. So those goal clips get stored on S3, and as the game progresses, as the game ends, we at the end of the game we trigger another montage process. That montage process is again put by this Lambda. What it does is it collects all the goal clips, sorts by timestamp, adds background music, converts the text commentary into audio using Poly, and then speaks it out in a human voice. So the end goal clip is the whole highlight video experience that you get.
Fantastic. So what we actually have a match going on right now, so you can see some of that commentary actually jumping up through there. So it's going to be the generative elements right through here. Shown in this, we got actually a little preview that's going to be coming up for that previous goal. But as you can see, tied into the foosball table, everything running from there. So, what were some of the unique challenges that you had incorporating a foosball table into these serverless architecture?
We had to go through several challenges. The sensors itself was a little bit unstable at the beginning. So then we ended up choosing a line sensor, just like your garage door sensor which detects anything moving. We ended up with those sensors. The Raspberry Pi was getting overloaded, overheated with a lot of compute processing. So we offloaded the compute processing. The Raspberry Pi only triggered this Lambda without having to worry about any compute. So it only sends the event via IoT core to this Lambda. So we made the Raspberry Pi less smart and we offloaded it to the backend. And there are a lot of orchestration going on if you see. Frankly, if we were to do this again, we would probably use that function for the orchestration if we redesign this architecture. So this was designed a couple of years ago. So we stuck with Lambda invoking various other pieces of Lambda processing. And we also had Kinesis video streams, which is a new addition this year, in order to make live streaming possible. So that's another addition that we had. On the UI side, we had a little bit of a challenge with the old Angular JS kind of AI UI. So we actually engaged our prototyping team, and they built a React JS powered UI by using some templates. So that was on the UI side.
Yeah, then we actually got another score. Just pop right back up through there. Yeah, and it's very real time. I mean, they will make a score that's very, very instantaneous that it actually shows up in those cases. You can see we have a very competitive game going on right now. You can see they just made a score and it immediately pops up with the information through there.
That's powered by AppSync GraphQL APIs. We have WebSockets. We were actually not sure whether Bedrock would be able to support a real-time commentary generation. We were surprised by the performance. It was producing millisecond latency.
Fantastic. Well, thanks for your time. Appreciate you showing us what you built. And we'll catch you around on a reInvent. Yeah, thank you.